Now let's flip this around and let's look at the titration of a strong base by a strong acid. Now in that case, the fundamental relationship between the H3O plus and the OH minus remains exactly the same in solution. That is, we have an initial condition determined by the pH of the original strong base, and if we're given a 10th molar potassium hydroxide solution, we can immediately calculate that. The pOH is 1, the pH is 13, and so that sets our original position at a pH equal to 13, so that's strongly basic. And then again we have an equivalence point, and at that equivalence point the original OH minus concentration, the hydroxide anion concentration, originally in solution is exactly equal to the concentration of H3O plus that's added. So we see that the behavior of the addition of a strong base to a strong acid is exactly the same in principle, except now we're starting with a base and adding an acid. And of course, as soon as we cross that equivalence point, the additional H3O plus that's added is identical to simply adding an acid to water.